Hello students. Yes, let us continue the inorganic chapter of chemistry, that is structure of atom. In the previous class we have studied atomic mass and atomic number, or also called as mass number and atomic number. And also we have discussed isotopes. What are isotopes, students? The atoms of the same element which have the same atomic number but different mass number are called as isotopes. Okay, let us study one more definition here, that is isobars. Yes, what are isobars, students? Atoms of the different elements. Okay, unlike isotopes. Isotopes, how we will define it? Atoms of the same element. But here isobars are the atoms of different elements which have the same atomic mass but different atomic number. Okay, atomic mass is nothing but what? Mass number. See, atoms of different elements which have the same atomic mass. Okay, same atomic mass. Instead of what I'll write here? Mass number. Okay, atomic mass is also correct, but generally instead of using atomic mass we are using the word as what? Mass number, isn't it? Okay, this is indicated with the value A, alphabet A, and different atomic number is represented as Z. Okay, atoms of the different element which have the same mass number but different atomic number are called as isobars. Okay, and carbon 14-6 and nitrogen 14-7 are example for isobars. Okay, what number is different here? This value of Z, that is atomic number of the carbon is 6 and atomic number of the nitrogen is 7, but they both have the same mass. So therefore these are what? Isobars. Got it? Okay, just make the difference between isotopes and isobars. And argon, potassium and calcium. Okay, you should remember value of Z will be different and value of A will be same, but and these both also will be of different elements. We are not taking carbon, we are taking carbon, nitrogen, argon, krypton, calcium, like that. Okay, what you should remember? You should remember the definition of the isobars as well as the respective examples. Okay, now we'll move on to one of the important concepts, that is electromagnetic radiation or electromagnetic wave. See, scientist Maxwell has given the idea about the electromagnetic wave. Okay, he proposed that a theory known as Maxwell's theory of electromagnetic radiation. Okay, before that we have to understand what is electromagnetic wave or what is electromagnetic radiation. See, electro and magnetic, this word is made up of two, this entire word is made up of two different words, electric and magnetic, electromagnetic wave. Okay, here the scientist Maxwell has told that when electrically charged particle or when a thermal body, when the heated body moves under acceleration. Acceleration means what? When it changes its speed. When an electrically charged particle moves under acceleration, alternative electric and magnetic fields are produced and transmitted in the form of wave. That is called as electromagnetic wave. For example, I'll show you, see. Yes. See, you just imagine these are the three axes. Okay. Okay. X axis, Y axis and Z axis. Okay. All three are perpendicular to each other. Isn't it? Yes. When an electrically charged particle will start moving in the Z direction, then what happens? The alternative electric, see, if this is the X axis, the electric field is produced in this way. Okay, yes. Next up, and also magnetic field is produced in this way. Okay, I'm sorry to tell you. See here, electric field is produced in this way and magnetic field is produced in this way. Hope you can imagine this. Electric field and magnetic field. Okay, both the fields, both the produced fields are perpendicular to each other, and the charged particle, they both together will moving in the z direction. Okay, both are perpendicular to each other and also perpendicular to the propagation of the wave. Okay, such type of wave is called as electromagnetic wave or electromagnetic radiation. Okay, what is electromagnetic radiation, students? When an electrically charged particle, okay, you just I'll dictate it and write it in your notes, write as electromagnetic wave or radiation. Okay, and then you write. Okay, yes, when an electrically charged particle moves under acceleration, the alternative electric and magnetic fields are produced and transmitted in the form of wave. Produced and transmitted in the form of wave. This is called as electromagnetic wave or electromagnetic radiation. Okay? Yes. Next you write as a note. Okay? The produced electric and magnetic fields are perpendicular to each other and also perpendicular to the direction of propagation of wave. Perpendicular to each other and also perpendicular to the direction of propagation of wave. Okay, this is about the electromagnetic wave. See, it will be like this exactly. Okay, I can, these are the three axes. Okay, one will be in this way and another one will be one on this. Okay, another one will be like this. Both will be perpendicular to each other and also perpendicular to the direction of the propagation of wave, students. Got it? Okay, next you write the side heading, Maxwell's theory of electromagnetic radiation. Okay, Maxwell's theory of, I'll write it in short, electromagnetic radiation. Okay, Maxwell's theory of electromagnetic radiation. Okay, see, now in the Maxwell's theory of electromagnetic radiation, he told what is electromagnetic radiation, how, when it is generated, and what are the properties of the electromagnetic radiation. See, to give an idea what are electromagnetic radiations, you just list out the different radiations, what all you know. For example, X-rays, what we say, gamma rays, radio waves, yes, microwaves, okay, and a visible light, okay, alpha rays, gamma rays, okay, visible light, X-rays, okay, these all are the part of the, these all together when we will arrange them in the increasing order of their frequency, we say that set of arrangement is called as electromagnetic spectrum. You got it now? What are electromagnetic waves? X-rays, gamma rays, okay, microwaves and ultraviolet rays. Visible light is a part of the electromagnetic spectrum. Means what? Any of the arrangement when different rays are rays together constitute to form a electromagnetic radiation. Okay, now you got what are electromagnetic radiation. In a wide range of electromagnetic radiation, I can able to see only the visible light, isn't it? So visible light is the part of the electromagnetic spectrum. Okay, generally let us study what are the properties of the electromagnetic spectrum. Okay, electromagnetic wave, properties of the electromagnetic radiation. Electromagnetic waves consist of both electric and magnetic field which are perpendicular to each other and also perpendicular to the direction of propagation of wave. That is how I have demonstrated. Okay, and electromagnetic waves do not need any material medium for their propagation. Okay, they do not need any material medium for their propagation, and this is the reason how we get the light from the sun, isn't it? Okay, in the sky no medium, it's a vacuum, but even the light of the sun can travel and it can reach the earth. Okay, that light is nothing but a part of electromagnetic radiation. Therefore, remember, electromagnetic wave do not need any material medium for their propagation. They do not need any material medium. They can travel in vacuum also. Okay, next, all electromagnetic waves travel with the same velocity. Velocity is nothing but in generally speed. All electromagnetic waves travel with the same velocity, that is velocity of the light. Generally, velocity of the light is what? What is the value of velocity of the visible light? 3 into 10 raised to 8 meters per second. This is the velocity of the all electromagnetic waves. Got it? Yes, because visible light is a part of the electromagnetic waves. Okay, all electromagnetic waves travel with the same velocity, that is velocity of the light 3 into 10 raised to 8 meters per second. Next, electromagnetic wave consists of different radiations and constitute electromagnetic spectrum. I said no, different radiations set together, that arrangement itself is called as electromagnetic spectrum. Okay. Maxwell's theory of electromagnetic radiation, if they ask, this is the same is to be written, or properties of electromagnetic radiation, if we ask, the same you have to write. Is that clear, students? So whatever I am telling you, you have to keep it in mind, because you are new to the syllabus now. So how the questions will be asked, you will not be having idea. So that I am explaining in the videos itself. Okay. How the question will be asked, what is electromagnetic radiation? What are its properties? Or generally explain Maxwell's theory of electromagnetic radiation. For both the questions, the same will be the answer. See, here I have shown you the electromagnetic spectrum. See, electromagnetic waves consist of gamma rays, X-rays, ultraviolet rays, and this is a visible light, okay, which again contains the 7 different colors, and infrared rays, microwaves, and radio waves. We have heard this all. Okay, these all comes under the electromagnetic spectrum. Okay, by taking what into consideration we have arranged this. These all are arranged with in the increasing order of their wavelength. These are arranged in the increasing order of their wavelength. For example, gamma rays have the lesser wavelength compared to X-rays, like this. Okay, increasing order of their wavelength. See, visible light, what all we can see from the bare eyes is just a part of the electromagnetic spectrum. It is just a small part of the electromagnetic spectrum. We can see from the 400 nanometer to 750 nanometer wavelength. That again consists of 7 different colors. Now you got an idea about the electromagnetic radiation. These all arranged, no, those all wave radiations are arranged in a certain manner, in the increasing order of their wavelength or in the decreasing order of their frequency. In the increasing order of their wavelength or in the decreasing order of their frequency is called as electromagnetic spectrum. Okay students, now you got an idea what is electromagnetic radiation, what are the properties of the electromagnetic radiation, and what do you mean by electromagnetic spectrum. Okay, yes. With this I conclude the class, but in the next class I have used the word here wavelength, frequency. Okay, wavelength, frequency, velocity, amplitude. Okay, the definitions of this wave number we'll study it in a different class. That is, next class we'll study those definitions as well as their SI units. Got it? Okay, thank you.